Well, we have another question here, question 6. The question says, in the diagram, the graph of f equal to 2 sine 2x is drawn for the interval x elements of -180 to 180. Now we have the graph here, and then we're going to do question 6.1. Okay, as we can see, the question says that on the system of axes on which f is drawn in the answer book, draw the graph of f of g of x, which equal to -cos 2x for x elements of the interval -180 to 180. Clearly show all intercepts with the axis, the coordinates of the turning points and end points of the graph. Well, first I'm first going to read the question here, question 6. We do have f of x equal to 2 sine 2x, and then x is elements of the interval 180 degrees to -180 degrees to 180 degrees. Now, question 6.1, we do have g of x equal to -cos 2x. Okay, and then they want us to draw the graph. Okay, it is important before drawing the graph to first find the intercept. Okay, if I need to find, let's say, the x-intercept. Okay, let's start with the y-intercept. Easier to solve. If I need to find the y-intercept, it's where we make x equal to 0. Okay, so in this situation, we're just gonna say, okay, y is just g of x, so it's gonna be y will be equal to -cos 2x. So over here, we're going to substitute the value of x by 0. Okay, because we are looking for the y-intercept. So this will be just y will be equal to -1, because maybe I should do it in the following line. That makes y will be equal to -cos of 0 degrees, and then cos of 0 degrees is just equal to 1. Therefore, the answer will be -1. You can check in the calculator. Move it over here. If you do cos of 0 degrees, this is 1. Cos of 0 degrees 1. Okay, it's this part that's equal to 1. Okay, and then we have a negative in front there that makes -1. Now we can also find -1. We know the x-intercept is somewhere, the y-intercept is there. Now for the x-intercept, x-int is where we make y equal to 0. So the equation is y equal to -cos 2x. So over here, we're going to set y equal to 0. So we sub in the value of y, 0 there. We can move the negative sign over or times the whole equation by -1. Okay, this will be, it's like doing something like negative here and negative there, and then we over here we had like 0 equal to -cos 2x. Okay, and then this is just -0 just 0 equal to cos 2x. Okay, so we can write like cos 2x equal to 0. And now this is possible only if 2x equal to 90 degrees or 270 degrees. That's where we got cos 2x is equal to 0. You can check with me. Cos of 90 degrees, it's 0. And then similarly, cos of 270 degrees, this is also cos of 270 degrees, this is also equal to 0. So we say that therefore 2x equals to 90 degrees. Okay, which means x is equal to, when we divide both sides by 2, we divide here by 2, we divide by 2, and then we get x is equal to 45. So this value of 45 tells us the intercept, meaning every 45, everywhere like every 45 degrees, we have the x-intercept. So when I look at my horizontal line, the x-axis, so meaning by 45 there, we have the x-intercept. Same also by 45 there, I get another 45 from this 45, which is okay, if you start 45 over here, you got to 90. So from 45 to there, it's another 90 degrees. I guess you get what I'm saying. So if you sub x is equal to 45, 2 times 45 equal to 90. So we have 45 here already, the x-intercept, another 90 from the 45, we got another intercept. Same thing backward also. This by negative 45, we have an x-intercept and another x-intercept there. Okay, so we can then start drawing the graph. How? We can by the help of a calculator. If I take my calculator here, I want to enter the values. I'm gonna do this first, press mode, and then select 7 for table 7, and then here I can just write a 2. No, I want to write negative cos of 2x. If I need to write x, please press this button here, alpha, and then select in your calculator x. In my calculator here is by this button here, by the parenthesis, close parenthesis, that's x, and then I can close the parenthesis. And then when I press equal, and it asks me, by default, it asks me to enter also the function for g of x, but I don't have any g of x here. I only have like one function that I need to work out. Don't confuse this g of x with the g of x we have here. It's not the same thing. So just press equal and then start. The lowest boundary, okay, the start value will be negative 180 degrees, and the height will be 180 degrees. So there I will enter negative 180, okay, equal, and by 180 degrees, and then equal, and then the step I will take 45, okay, 45. Now, when you hit equal, and then we have the table of values. So this tells us that when x is negative 180 degrees, f of x, which is in this case g of x, will be negative 1. So there I'll say it's going to be negative 1. Now and then also we can see by if x has the value of negative 135, f of x will be 0. In this case, g of x is 0. This was done already when we were calculating the intercept. And if x is negative 90 degrees, that's going to be 1. So over here, it's going to be by 90 degrees, negative 190 degrees is going to be 1 there. It's going to be 1 over here. And then that also is going to be 1. We can check. We can just move this down by negative 45. We have 0 as we had there, and then by 0 it's negative 1. We have it already, and then by 45 it's 0. We add also, and then by 90 it's 1 as proven. So now we're going to do the graph. Now I will advise you, try to do some effort to do not draw your graph like this, okay? Because they're not like these, it's not like similar to these slides. There must be curves. So what we can do is like maybe start by the turning points, okay? Try to make them a little bit round, okay? And then something like that. Now we can then start drawing, try to make it a curve, avoid making it look like straight lines. So things like that. Yes, approximately. Now we have like answer to 6.1, and then question 6.2. 6.2 is here. The question says that write down the maximum value of f of x is equal to equal to 3. So now I'm gonna move my board over here. Split it like that. 6.2, and then we want the maximum value of f of x equal to 3. Now, first of all, f of x is given by 2 sine 2x, as we can see here as given. Now, so if I need to find the maximum values of these, so if I need to find the max okay, before even write max, I can just say we have like f of x equal to 3 simply means 2 sine 2x equal to 3. Okay, so to find the max, this will be the max will be 2 sine 2x. We move the 3 over, so it's gonna be minus 3. Okay, and now it is important to note that sine and cos, only the two trig functions sine and cos, are bounded between -1 and 1. Okay, they're not more than 1 or lesser than -1. So the maximum value is 1. All this, what I added here, has a value of 1. Okay, it has a value of 1. So the max of f of x will be then equal to 2 times 1 minus 3. Okay, and then this will be 2 minus 3, and this is equal to -1. That's the maximum. Then the following question is question 6.3. This one, the question says, determine the general solution of f of x equal to g of x. Okay, I'm gonna move my board like this. 6.3. We want to prove the general solution, so the value of x, that's what the values of x for which f of x equal to g of x. This is what we're looking for, those values of x. Now f of x is given by 2 sine 2x, and then g of x is given by negative cos 2x. Luckily, in this case, 2x and 2, we have like this, the angles are the same. So we can, I think we can now divide by cos 2x both sides. Okay, we can divide both sides by cos 2x. I know that's by doing so, this part here is just equal to 10 of x. Okay, all this is just 10 of x, 10 of 2x, I mean to say, sorry. So can just, okay, so this means 10 to x equal to -1, because cos 2x over cos 2x over here we just simplify, it just makes 1. And then if I need to find, I'll divide by 2 both sides, and then we'll get 10 to x equal to -1/2. Now I need to find this angle 2x, the value of the value of the angle such that 10 of 2x is equal to -1/2. First of all, from the trig circle, right, in the SOHCAHTOA, for the 10, we know that 10 is positive on the first. 10 is positive on the first and the third quadrants, meaning it is negative on the second and the fourth quadrant. So we are interested in these quadrants here, the second and the fourth quadrant. Now, in the second quadrant, what we have, if they say like 10 to x is equal to 1/2, what is the value of 2x? 2x will be equal to what? When I use the calculator, press on and then press mode and then 1 to get the the mode 1. And then 2x will be equal to, we're just going to press shift 10 of negative a half. Okay, of negative a half. And this is equal to negative 26.565, etc. So when we get the negative answer like that, plus 180 to it to get the actual angle. So the angle is like 153 in the second quadrant, as you can notice. Okay, in the second quadrant, 153.43. So it's going to be 153.43 plus, always you plus 360 k times k. Okay, then because we need the value of x, we will divide both sides by 2. Okay, we divide both sides by 2, and then we get x will be equal to this will divide by 2, it's 76.72. So that makes 76.72 because we are going to round the second decimal place. We're going to look at the third decimal value, and then we're going to increase the second decimal value by 1 unit if the third decimal value is 5 or more. Like in this case, the third decimal value is 7, so we increase 1 by 1 unit, that makes 72. And then plus 180k. This is knowing that k here is an integer. Integer is denoted by the symbol z. That's what's on the second quadrant. Now on the fourth quadrant, I want to do it over here. So we did this part. Now on the fourth quadrant, we will say 2x will be equal to, remember we got negative, okay, let's do it again. You press shift and then 10 negative a half. Okay, close bracket, equal to that. Now over here in the fourth quadrant, these are the values that are we're going to do 360 degrees minus this number, or just do this number plus 360 degrees, plus 360 degrees, because that value 333 is in the fourth quadrant. Okay, so we have like 333 point 43. That's 43. Okay, plus 360 k, knowing that k is an integer. And then to find the value of x, we will divide both sides by 2, all this by 2, and then by 2, and then we will get x equal to, where's my calculator? This divided by 2 is 166.72, 166.72 plus 180k. Okay, therefore we can answer the question. Okay, it was done this way. We can say therefore x x will be equal to 76.72 plus 180k. Okay, 180 degrees k, or x will be equal to 166.72 plus 180 degrees k. So these are the values of x. Thank you. And then we have another question, question 6.4. Question 6.4. Excuse me. The question says, hence determine the value of x for which f of x is lesser than g of x in the interval x elements of negative 180 to 0. Okay, so I'm gonna move my board over here. So 6.4. Now we still want the value of x, the value of values of x, for which f of x is lesser than g of x in the interval. Now the interval is negative 180 degrees to 0. Right. When the question says hence, it means we're going to look at the previous solution. Okay, so let's first look at the graphs. Or maybe let's just reproduce. No, let's just look at the graph. We can notice that f of x is lesser than g of x in this interval, in this part from here to there, because this is where g of x is more. Okay, and also in this interval. So here, as you notice, f of x is smaller than g of x, is smaller there. So I didn't want to draw an ellipse there, or something like that. Okay, I guess you see the interval. So from there to that point, now it means they're equal at the point of intersection. So this one, they're equal here at this point of intersection, and then those are the very points which will determine the boundary over which f of x is lesser than g of x. Okay, so if I want to move my board over here, let's say that's they're equal at this value, because the previous question we show where they're equal. Okay, we prove that f of x is equal to g of x, and then the answers are these values, 76.72 plus 180 degrees k, or at this point. Now, it's first of all, if k has a value of 1, for instance, we already exceed the upper boundary. Okay, so we can see that if k is 1, the answer will be like 270 something, 276, and 250. It's going to be more than 0 here. So k cannot be 1. I'm going to take a value lesser than 1. If I take a value like 0, for instance, if I take a value like, if k has a value of 0, then that's going to be 76, which is also beyond the interval. Then I must take a value lesser than 0, negative number, like -1. If I sub in -1 there by k, if I sub -1 here by k, what we will get 76 minus 180 degrees. Okay, and then check in the calculator. If we do, for instance, 76.72 plus 180 times -1, okay, and then this will be equal to, oops, sorry, let's correct. I think I put more parentheses like that, and then there we have like -103.28. Okay, on the right here, -103.28, and then over there also something in this part, something. If k has a value like 1, it's going to be beyond the interval. If it's 0, it's also beyond the interval. But if I take a value like -1, for instance, there, I'm going to get here, let's see, 166.72. There, press equal, and then press SD to find the actual value is -13.28. So we have a value like negative 13.28. So the value of x will be then from -103.28 to, so we can say lesser than, okay, lesser than x, and then lesser than negative 13.28. You can write like that, or you can also use the interval notation, not this interval, but round the interval, negative 103.28 to round interval, because we want, the question clearly say that those are lesser than, okay? So meaning where they're equals excluded, are not part of the interval. So negative, over there it's going to be negative 13.28. Thank you.